Back with part 3, the dreaded part 3 video, but I'll try and keep her short. We got this last example, and this is from a description. It's not even from, a situation that we're looking at, like the basketball pass. We're not given the model. This is basically just a story, and we're going to be able to come up with an entire model and answer questions based on just the story. And again, pause the video and read it, okay? Because I'm going to answer it here shortly. So pause the video and read it if you haven't read it. All right, off we go. A, state the period, amplitude, phase shift. Again, I'm going to do this together. A and B I'm going to do together, and I'm just going to sketch it all in one shot here. This idea is that owl populations, like a lot of animals, the population fluctuates periodically. Okay, so what does it say here? It says the owl population is at an all-time lows of 890. So that gives us the minimum, right? The minimum is 890. And that's right now. Last time it was this low was back in April. So here's April. April, and then now. That gives us the period, right? We'll have to figure out the period. And this was when now would be October. So that's October, and this is April, and at an all-time low. He said last time it was this low was back in April. Seems like back in July they was doing their best, and that was 1,110 owls. That's the maximum, and that was in July, probably halfway between the two lows. Would you guess? July, and it says n equals 1 represents January, so April is the 4th month, July is the 7th month, and October is the 10th month. And this is, very familiar sort of numbering of months. And so what's the period, amplitude, phase shift, and so on? Well, let's state it. Well, the period, notice that low to low was 6 months, right? 6 months. So the period was 6 months. The amplitude, well, I don't know what the amplitude is because all I was given was the minimum and maximum, right? So the amplitude and vertical displacement, I don't know. There's the amplitude. Here's the vertical displacement. How do I calculate it? Well, let's do the vertical displacement first. The axis, which also, by the way, is the average number of owls we've got. 890 plus 1,010 divided by 2. That looks a lot like 2,000 divided by 2, which is about 1,000 owls. 1,000 owls. So the amplitude then is from the vertical displacement to the top is 110. Subtract 1,000 is 110 owls. That's how much it fluctuates. What else? Tick, 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 tick. Minimum, maximum, got that. Sketch the function. Dandy, we've got all that business. And then using this information, determine an equation. Can we do that? We need a phase shift, right? We've got a phase shift to 4 months. So we'll have to be aware of that. Certainly, I could use a sine graph, but I'm going to use the flip coast graph because it starts at its minimum. I could do a coast graph that starts at its maximum, I suppose, and use a phase shift of 7, but I'm going to just write a coast graph. And since there's no pi's along here, I'm going to have this application. They said t, right? Time is t, minus d plus c, and then I can fill in these. Well, the period is 6, so big B is 6. The amplitude, this is A, which is 110. The period was 6 months. The phase shift, to get to a starting value of 4, I could write in T minus 4 and up 1,000 owls. Notice Right now, that would have me starting at a maximum, so I do got to make this minus at the beginning. And again, let's use the notation they wanted us to. So this is the population after time t, and there she blows. And then it says, asks me, using the equation above, determine the number of owls in the following months. August of 2007. So August of 2007 is in here somewhere. August is, this is C part 2, I guess. It's a little silly, but for A, DA, August is N equals, August is the 8th month. And so I just pound that into a calculator, right? Put in T equals, not N equals 8, but T equals 8 into the calculator, and you should get an answer. Careful, careful, careful on the calculator, is about 1055 owls. Does that make sense? Well, certainly it's above average, right? July, August is a little bit above average, a little bit of above average. That makes sense. Dandy. Using your graph, and again, you can do B and C, and it's all good. Using your graph, predict the month when the owl population was 1,000 owls. Well, that one we should be able to get exactly, because that's kind of one of our important points. This is exactly halfway between the minimum and the maximum. Also, again, between here. So this is, this was 3 months, right? So this is 1.5 months. So at t equals 5.5, or what's that? Mid-May, halfway through May, and also right here, which is 1.5 months from July. Also t equals 8.5, which is, well, that's mid-August. Mid-August, which makes sense. Early on in August, August 1st, it was 1,000, and then it's going downhill. The instantaneous rate of change is negative. The population is decreasing, and then by mid-August, it's at 1,000. And this is the answer for EA. And we could think of these other ones as well. Less than 950 owls. Well, that's, you guess, somewhere in here, and it's quite a lot of the year. Well, not quite, some chunks where it's less than 950, and you can read that straight from the graph. Again, we can't use the equation to get this exactly yet. Okay. Have some fun with these. In the homework, there aren't very many. Where's the homework? How many have we got? It says 5 through 11, but again, you can get through them pretty quick. One thing I wanted to point out is this note here. You may want to do next day's 3-minute review in class today, because it uses a TI-83. So think about doing that, and I'll even let you get away with skipping 1 or 2 of those so you can get to that 3-minute review in class. All right, that's it. Video 3, long lesson today, but it's good, clean, Trig app fun.